So this is question 2 of the Sample Assessment Materials Paper 1 Higher Tier for Physics, Edexcel 9 to 1 GCSE. Scientists no longer accept the geocentric model of the universe, but it was the accepted theory for hundreds of years. Explain why the evidence at the time supported the geocentric model. So the geocentric model is the idea that the Earth is at the centre of the universe. And we know that's not true now. We know that the Earth orbits the Sun, and that the Sun is not the centre of the universe. But for many, many years, they thought the Earth was at the centre of the universe. Why? Well, hundreds of years ago, they didn't have telescopes, so all their evidence was what we call naked eye observations. So they could only see what they could see with their eyes. And when you look with your eyes, you notice that the Sun and the Moon, and indeed the other planets, which look like stars, but fuzzy stars if you see them on without a telescope, they appear to all move across the sky in the same pattern or motion every day. The Sun rises and then sets, the Moon rises and sets every day. And this suggests that the Earth is at the centre and that they're going around the Earth. It's what you would, if you didn't know what was happening, it's what if you see the Sun going up and down every day, you'd expect it to do. So that's why we thought the Earth was at the centre of the universe, because we didn't have any evidence that it wasn't until we had telescopes to be able to see things in more detail. And part B, the Big Bang Theory and the Steady State Theory, are two theories about the origin of the universe. The discovery of the CMB, that is the cosmic microwave background, led scientists to accept only one of the theories. Explain why redshift supports both theories, but CMB supports only one of them. So, when I was at university, I didn't learn about the steady state theory because it's not believed anymore. But in your GCSE, you need to know about both of them and why we don't think the steady state theory is correct. So redshift is evidence that the universe is expanding. So when a star, or a galaxy as you really think about it, is redshifted, it means that the light from it has been stretched, which means that it's moving away from us. And 99.9% of galaxies that we observe in the universe are redshifted. There's only a couple that are blue shifted, which are coming closer to us, and they're the close ones to us, like Andromeda. So the fact that most galaxies are moving away from us is evidence that the universe is expanding. Now, an expanding universe is part of both the Big Bang, and I would write it as Big Bang, not BB, but I'm being lazy and have less room, and SS, steady state theories. Therefore, redshift supports both. Both of these theories were decided upon and theorised after Hubble had discovered that the universe was expanding, so they had to have that in there. However, the Big Bang Theory states that the universe has a beginning, and the steady state theory does not. So the steady state theory says that the universe has always existed, and it also says that although it's expanding, it has a constant density because matter is constantly being created, whereas the Big Bang Theory says that the universe has a beginning, and as it expands, it becomes less dense as things spread out. The cosmic microwave background, or the CMB, is evidence that the universe had a beginning and so supports only the Big Bang Theory. The cosmic microwave background is really hard to explain at GCSE level, but if you think about the Big Bang, it was a very high energy moment. It wasn't an explosion because, anyway, we won't into that right now, it's one of my pet peeves. But it was a very high energy moment, releasing lots of gamma rays and X-rays. And since then, it all happened in a very, very small space. And since then, the universe has expanded, and that really, really high energy has expanded with it. And it has gone from gamma rays and been redshifted to X-rays, then to UV, then to visible light, then to infrared, and it's finally now it's microwaves. So it's redshifted over leftover energy from the start of the universe, which is why it's evidence only for the Big Bang. Okay, question 2C. A star with a mass very much larger than the sun. We've got 4 options here. So stars with a mass much larger than the sun is either a longer or a shorter main sequence. Massive stars have a much shorter main sequence, so this is correct. It can either be C or D. Right now it has a shorter main sequence. It's a little bit like if you've got a small car or a big car. If you've got a small car like my little Panda, I can go quite a long way on a small tank of petrol because it doesn't burn through much petrol. But if you've got a big car, a big sports car, like a Ferrari, although it might have a bigger tank, it will burn through it much quicker. And it's the same way with a large star. And then we've got either ends as a white dwarf or ends as a black hole. So if a star is like the sun, it will end as a white dwarf. If a star is much bigger than the sun, it will end as either a neutron star or a black hole. And a black hole is if it's the bigger end of that. So it's going to be D that we're looking at here. And then which row has 2 correct statements about black holes? So the first column, gravitational field of a black hole allows only EM radiation to escape or allows nothing to escape. It allows nothing to escape. It pulls in even light, which is a type of EM radiation, and it's formed when a nebula collapses or a large star collapses. It's formed when a very large star collapses in a supernova. So it's going to have to be B, as that's the only one that has both answers correct.